Good morning. Welcome to SCI and our live line demonstration. My name's Donnie Taylor. I'm a journeyman lineman with SCI. I've been here 25 years. And before that, I worked construction for 6 years doing the same work. With me is Rudy Flay. He's been here 5 years, and prior to that, he worked at Johnson County REMC for 5 years. John Campbell, he's been here 2 years, and prior to that, he worked outside construction for 2 years. A little of what it takes to become a journeyman lineman. It's 4 years, 8,000 hours of book training and actual outside on the job training. Some of the steps we go through, actually climbing school, learn how to climb the pole. You've got hotline school where you learn the rubber glove. You've got basic and advanced underground school to work on the underground lines like these. And material handling school to learn to set up bucket trucks and how to use the jibs, that everything that's involved with it. A little bit about the demonstration. So electricity is generated at a generating plant, whether it's coal, natural gas, wind, solar, hydro, or nuclear. Our generator outside is actually acting as our generating plant. It's putting out 240 volts, and we come into this transformer at the end where it's labeled substation. These transformers are actually stupid. You can send 7,200 volts in the top, and it'll transform the voltage to 120, 240 coming out the bottom, or like we're doing, we're putting 120, 240 in the bottom, and it's coming out 7,200 at top. So it's going through our substation and coming down the power lines, and it's coming over here to this other transformer that you have at your home, and it's coming in 7,200 volts at the top, coming out 120, 240 at the bottom, going through your house meter and coming out and lighting up this light. Now, some of the equipment we have on the pole, when you hear us talking about cutouts, it's these devices here. Those are generally what we have at our transformers, some of our line taps. So if we have a fault, a tree, a squirrel, whatever, a lot of times those will open because they're a one-time use type operation. As soon as it blows, it drops open and we have an outage. And we'll come out and repair that outage. Now on down, right here, we have what's called an ECR. It's an electronic circuit recloser. It takes 4 shots before it locks out. And what that does is we've got a couple fast shots, so instantaneous, it'll trip and come back on, and hopefully the fault has cleared itself already. Then it'll go into 2 longer curves that actually are called burn curves. And they will sit there, if there's a tree on it, it'll try to burn that tree off. Or if there's a squirrel hung up, it's going to try to burn it off on the next 2 shots. If it doesn't clear itself, or the line actually burns down, that's when that unit will actually go out on its 4th shot and lock out. It'll de-energize the line. A little bit about some of the table items here. As you can see up here, we've got our different wire sizes, and there's myth with our wire that's in the air that it's insulated. It's not insulated. There's another myth that there's 240 volts going across the top. That is also false. There's 7,200 volts single phase, 12,470 volts phase to phase. And phases, I mean, is what's carrying the electricity. We've got a phase and a neutral up here. With alternating current, it goes out the phase and it's seeking a return path to the source, which is the substation. So you're going to have a circulating current. It's going to come out on the primary and come back on the neutral. We'll actually show you voltage on this neutral when we get to that point to test it. With the wire, generally on our system, we'll have a lot of aluminum, but it's not all aluminum, it's got steel in it. And we have copper clad, which this is the clad steel. And your subdivisions, your underground subdivisions, are going to have underground primary feeding them. This is, I believe, million. Yeah, it might be 750. 1/0. This is the underground that actually feeds houses in the subdivisions that have the green transformers that are on the pad mounts. This is aerial. If we're coming off of one of these transformers here, we can either go underground off that transformer to a home or overhead to a weatherhead. Now the first step, they're removing the grounds. So anytime we actually go out and work on a line that's had a fault on it, we'll electrically isolate the line and put grounds up to protect us while we work. That's just in case the hairy homeowner decides to hook up a generator and he actually hooks up the generator incorrectly like we have, and it actually puts power on the line. So we're going to create a fault and show you a little about how it's going to happen. Not too many people jumped on that. That's interesting. So the owl created a dead short to the ground. So that was an instantaneous fault. And our one-shot device, that's what they sound like, about like a shotgun, it opened and cleared that line. Now we have to come out, roll a truck, go out and find out what's wrong, repair it, and put you back in service. Now we're going to show you what a three-phase device is on our downlines. This is an electric circuit recloser, and it's not going to make any noise. That was a one-shot. This will go 4 shots to lockout. 1, 2, 3. Long burn. And it locked out. So generally when that happens, power line may be down on the ground. And that's another myth. If a power line's on the ground, is it dead? No. If we have snow on the ground, the power line's on the ground, you can bet that it's going to be hot. The snow is an insulator. So here we're using a DVI, a digital voltage indicator, to check voltage on our circuit. We're running 6,700 volts. Now on our neutral, we have 1,700, 1,800 volts coming back to the source. So a neutral will kill you as fast as a phase, because people start taking half steps when they're dealing with neutrals, and it's just as dangerous. Now, you go to a birthday party and kids like Mylar balloons. They love them. And what's one of the things that they do as soon as they're done with the Mylar, had fun, it's full of helium, what are they going to do? They're going to let that sucker go, right? Well, the Mylar is extremely conductive. It's extremely conductive. As you see here. You see the light lit up, and you can see the current actually going around that Mylar balloon. It's lighting this light. So there's 7,200 volts passing through that balloon around the surface and lighting this light. Kids like to let those go, but we tell the parents as soon as the kids are done with it, we want you to pop them. The Mylar floats on the wind current, and just imagine some of our transformers in our substations are $500,000 to $1 million. Just imagine that getting up between the bushings on a transformer and tearing that transformer up. And transformers nowadays are extremely hard to get. We got a demonstration on a hot dog hand. The reason we use hot dogs is it resembles a human hand. It's got a skin, it's got fat, it's got gristle. And the aluminum we're actually using is the bones. Now electricity, if you do have a contact, it burns from the inside out. So the first thing that's going to affect is your bones. If you want to pass that around. You can look at the tips of those and see how they're burned off. So it starts at the bones and slowly works itself out. If you've had a bad contact, when you get to the burn unit, one of the first things they'll do is they'll start cutting you open. Just start making slices in your skin, because the skin is going to slowly swell to where it actually rips the skin. So they're going to make places in your skin to where it actually comes out and it sews up a lot better than tears. And we know a few people that have actually lost limbs in this industry. Here we've had Harry homeowner on a weekend decide to cut a tree, and it falls down into the primary neutral. Now, in an instance like this, please do not cut that tree off the line. If it's on a power line, do not cut that tree off the line. That's our job. You have no way of knowing if that line's de-energized. That electricity will go from that power line straight down that tree to the ground, and it will be energized. We've got another one we've just started doing. We use these rubber gloves as part of our personal protective equipment, and we test them every day to make sure they don't have holes in them. We've actually put a pinhole in this one, and we have a hot dog up inside of it. So before every use on our personal protective equipment, we'll actually do an air test. You can see how small that hole is if you want to pass that around. And you can see the tip of the hot dog just like the other one, but this actually had rubber glove protection. It just had a small hole in it. Talking about our PPE, our personal protective equipment. Rubber gloves with our protectors and rubber sleeves. Anytime we're dealing with primary voltages, we're in this. Along with our hard hats, our safety glasses, our flame resistant clothing, and our composite or steel-toed boots. Now, earlier the owl caused an outage. Now we're going to show you a type of arc that we can create with the owl. This is a fun part of it. They always have so much fun on that part. Another one, we've got our PVC guy. He is acting as one of us. And we use a grapefruit to show the body, the way the electricity goes through the body. And we're going to set him up here in front and actually pass current through him. Electricity burns from the inside out. So it'll start on the bones and slowly work through the fatty tissue out through the skin. So you can see where the electricity's gone down the center and it's radiated out. This here in the center where the electricity actually passed through is extremely hot and charred. You get on the outside of the grapefruit, it's actually cool. So this is actually showing how the electricity cooks from the inside out. I would pass it around, but it's kind of messy. Now, on any given day, we're dealing with car accidents with utility poles. And sometimes the power lines actually fall down on the car, and we tell people stay in the car if at all possible. There's going to be instances where they have to get out if the car's on fire and it's worried about life and limb, but there's certain ways that we try to teach the public to do that. Let's say this yellow line right here is the edge of the car. So you're going to get out of your seat and stand on the edge. And to get out of that car, you're going to take a hop. We got some that time. And you're going to hop and hop, bunny hop, as far as you can. If you can't bunny hop because your back or your knees, you're going to hop out of the car and you're going to shuffle. You want to keep your feet together and shuffle in contact with the ground, and it's heel-toe. You don't want your heel past your toe, otherwise you will get step potential. If you step off like this, you're going to have a different potential of electricity from here to here. It's going to go up your system and you're going to fall dead right there. And as first responders, you need to know walking into that situation, you can walk into it yourselves. Now, some of the stuff we use, which all the guys using, was this this shotgun right here. That's what we use to actually take devices off, like our grounds. Rudy has the long stick, or extendo. We use them sticks in the middle of the night when we go out and we find a squirrel at the ground. We'll run it up and take the cutout door out of the cutout, pull it down, put a new fuse in it, run it back up and close it, and hopefully your power comes back on. If not, we're going to be there a little longer. But we will find out that issue and get your power back on. Well, thank you for coming.